Hello, everyone, and welcome to the latest edition of the Lightning Interview Series. As always, we want to make these sessions interesting and interactive. So don't forget to introduce yourself and tell us where you're joining from and what you do. Now, today's interview, as you well know, is with Dr. Shailesh Kumar, and the topic is the evolution of AI use cases and data science skill sets over the next decade. But before we start, a quick word about upcoming sessions here at ODSC and AI Plus. So as you know, next week is our ODSC APAC. It's our virtual conference for the APAC region for 2022. Super excited about that. We've got over 50, I think it's closer to 60 speakers and sessions going on there. And for this year, because we're trying to get out of pandemic mode, we're actually hosting a number of meetups as part of that event, including meetups in Bangalore and Manila. In Manila, we got two talks. One is on building efficient neural networks, and the second one is on self-supervised learning for NLP and computer vision, which is a pretty hot topic. And in Bangalore, we got Vasmi PK, who's the commercial data science lead at American Express, and he is talking on risk management, where analytics and data take center stage. So if you want to get out there, do a little bit of networking, get off the laptop, your workstation, and meet some people if you're in the areas there, that's a great chance for you to do so. Now, on September 16th, we're going to continue our Lightning interview series with Professor Peter Abil, who you may know is the co-director of the world-famous Bear Lab at Berkeley. And we also have our in-person conference in San Francisco, which we've been talking about a lot. That's back in person on November 1st. So just a quick word on ODSC APAC. Virtual passes are still available. And as the slide says, it's a virtual event that you cannot afford to miss, especially since it's free. And a few quick words here. We are still running our AI Plus Careers platform. Remember, at all our conferences, we used to do career fair matching. I know a lot of you are upskilling, reskilling, just starting out in your career. What this platform does, it's essentially, it's something we built here in-house. It's a recommendation engine using NLP. You upload your resume. It matches you for pretty much every job out there. So instead of going out to searching all the job boards, it'll do a recommendation for you. It'll do a skill match and all that good stuff. So check that out. And I know we have a career fair coming up for ODSC West, but we already have a number of companies we're working with there. So, and by the way, if you are hiring, this is a free community service. So send us your jobs and we will get them on that system for free. And then lastly, I want to definitely mention our AI Plus online training platform. This session will be recorded, and every Lightning interview we had prior is on this platform. There's also over 600 free videos from our various conferences on there. Then if you want to upgrade to one of our paid plans, we've got lots of boot camps and certificates on there to check out. All right, so let us proceed with today's show. I'd like to again introduce today's guest, Dr. Kumar. Now, Dr. Kumar is currently the Chief Data Scientist at the Center of Excellence in AI and ML at Geo, very well-known Indian company. And he's quite accomplished. He's published over 20 international papers and book chapters and holds more than 20 patents in AI and ML, and has been recognized as one of the top 10 data scientists in India by Analytics India magazine. Dr. Kumar, welcome to the show.
Hi, thank you. Thank you for inviting me. It's a pleasure to be here. Looking forward.
And Dr. Kumar, again, thank you for being a repeat ODSC speaker. I know you've spoken at quite a few of our events, and we'll talk about your upcoming session at ODSC APAC in a little bit. But I want to start a show as we always do. Tell us about your path to becoming this distinguished expert in AI.
All right. So, that journey started almost 20 years ago when I did my first internship in a area which is called genetic algorithms. And that's when I realized that this is the kind of thing I want to do. Traditional computer science, everybody knows how to do good programming and compilers and networking and all of that. So I realized that this field of AI is really going to shine because it has a metaphysical element to it, it has a research element, it has a very futuristic element to it. And really, it's about the brain thinking about the brain. And that recursive nature of AI is what got me hooked. And then I went to UT-Austin, did my master's in sort of a computer science kind of AI, which is symbolic AI and all of that, planning and machine learning. And then my PhD in more on statistical AI. So I kind of got both flavors of AI. So I'm a combination of neural as well as symbolic person. Then I joined. My first job was a research scientist in a company called Fair Isaac Research in San Diego, where they do a
Oh
lot
yeah.
of work on credit modeling, credit card fraud, and I also got an opportunity to work on blue sky research for three-letter organizations in the US, and that's where I kind of learned and picked up a lot of vision, speech, way before kind of the modern day deep learning came in. And since we were supposed to be blue sky, we kind of almost invented some of the deep learning ideas back in 2003.
Right.
So I got a good handle on how to build industry scale credit models, credit card fraud models, way before the cloud was invented. And then we moved to India. I kind of got into Yahoo Labs, worked there on image search. And that's where I learned about how to think scale. And so in the first job, I learned about accuracy. Now I'm thinking about scale. We worked on image search at Yahoo, and we built some very interesting models, won a lot of awards for that. Then I joined Microsoft for a short duration, worked on query processing, query understanding, and then Google for 5 years, where I worked on a lot of NLP and unsupervised learning approaches. And one of our internship projects kind of sort of became Allo later. So we started this dialogue act based conversation systems. Apart from many other things, I worked on Gmail, YouTube, and all of that, but mostly NLP and big data kind of stuff. Did my own edtech startup after that, 5 years at Google. I'm very passionate about how AI can be used to solve social problems. So I said, let me try that. There we built a mathematical reasoning engine which could solve any math problem, sort of like Wolfram Alpha from scratch. And our moment of the big aha moment was when we put, integral calculus knowledge and algebra knowledge and gave a problem that needed both. AI actually solved the problem because it had both the knowledge bases. And that was the aha moment. And then I realized AI, unless it gives you that aha moment, which says, hey, are you doing something beyond what you had programmed it for? We all build models to have high accuracy, but unless it does something beyond your
Right.
programming, it's not AI yet, right? So that was a very nice, realization. Then I got into Ola Cabs, which is the Uber of India, where I learned really about real time thinking. And so scale I learned at Yahoo and Google. Uh, Reasoning I learned at my edtech, and then real time decision making at a very large scale across a very large type of decisions, right? Pricing decision, allocation decisions, campaign decisions, and all that. How do you think about multiple decisions happening simultaneously in a complex system? So that's when my idea of next generation systems evolved, which is going to be different, and we'll talk about it. Where real time, many things going on simultaneously, they're all affecting each other. That kind of thought process evolved. And then now I'm working at Geo, where I look at many different verticals. I look at retail, telecom, refineries, healthcare, agriculture, sports, quantum computing, sustainability, and genomics. So we have like a very diverse set of verticals that we look at. And we are looking at how to cross pollinate ideas, how to think, bring a new kind of AI thinking into all of that, so that can we create a common operating system for AI, uh, and that can be applied across verticals. So that's where we are now. How do we think about AI at an ecosystem level, top down? So it's a very interesting journey. I grew up with the field. I'm also mentoring Geo Institute, which is now started a Geo, AIDS program, and we have the first batch going on. So all this learning we have put into that program. So that is my second day job, and it's kind of fun that we are able to both contribute to one of the largest conglomerates in India, and obviously start an education program around this with all the learning. So
Yeah, so I got to say that has been quite the journey, Dr. Kumar, and I love that you followed the whole evolution of data science, AI, and machine learning, because I know doing NLP 10 years ago is different from 5 years ago, and it's definitely different from the last 2 years, and it's computer vision, and everything's changed so fast. But I think a lot of people, especially those of us who come into it in the last 5 or even 10 years, don't realize the amount of work that went into AI and data science and related fields over the last couple of decades. Um, and by the way, for our audience, please do share your questions. Any questions for Dr. Kumar or myself, just put them there in the chat bot. So you mentioned geo, and I was looking at your LinkedIn profile, and what struck me was the breadth of what you're doing there at Geo, because I think the blurb was reimagining education, agriculture, healthcare, mobility, energy, safety, security in the era of AI. So you've already touched upon Geo and your role there, but can you expand about it on a little bit?
yeah,
Because
sure.
I'm especially interested in some of the more advanced fields we're looking at, such as quantum computing, and definitely what's going on at the Research Institute and an educational initiative, because I think that feeds into our topic here.
Yep. So basically, the idea is that in the last 20 years, we have figured out how to build great one-off use cases, right? So how to build great search engines, how to build great recommendation engines, whether it is Amazon
Yeah.
or Netflix, how to run, these businesses, how to do, marketing and sales well, how to run ad services. So we have dabbled in very deep, very specific use cases of AI and done a great job at it, right? We have figured out how to do scale, how to do accuracy, how to retrain the models, and all of that. So we are now quite mature in our AI thinking for a few verticals. Now, Sundar Pichai said something important. He said recently that AI is one of the most important things mankind has ever done, and when I talk to our farmers, our teachers, our students, our people on the ground, they don't see it that way. So I think the next 20 years of AI is not just going to be a better version of search, a better social network, a better metaverse. It's also going to transform society at a social use case level. So unless a farmer can get a very personalized advisory every day, what to do, based on all the data that we are collecting about him, which is the weather, the soil IoT, the satellite, the nearby prices, supply chain of everything. Unless we can solve individual problems like that, how about a student getting a personalized advisory on what to study next, right? And AI was supposed to be one of the early use cases of education, was supposed to be one of the early use cases. If you search for the word teaching machines, BF Skinner has done a lot of work on teaching machines in the 60s. And even today, Netflix is highly personalized, but education is not personalized. You see the dilemma. The dilemma is we have applied
Yeah.
AI to all the great commercial use cases, but now is the time that we start putting all our efforts into social use cases. Healthcare is picking up very big time post COVID. We are now integrating a lot of Fitbit data and diagnosis and all of that to create a very comprehensive health scorecard. And one of the things we are trying to do in my omics research is what role does genomics play, what role does epigenetics play, what role does biomics play in health, right? Going deeper, not just at the Fitbit level. So how do we think about health deeply, education deeply, agriculture deeply? So Geo being a 5G company or a telecom company is not the end game. Really, what we want to do is transform society. While 5G is one of the enablers, cloud is one of the enablers, AI is one of the enablers, how do you put all this together? And devices is one of the enablers. Blockchain, AR, VR, these are all enabling technologies which are completely worthless if we are not uplifting society with all this technology coming together for the farmer, for the teacher, for the health worker on the ground in tier 2, tier 3 villages. So I think the next wave of AI and this conglomerate of technologies is going to be a catalyst in social transformation of mankind, not just commercial transformation, which we have already seen, right? And the
Yeah.
other areas, industry, manufacturing, and all of that will get uplifted. How we run systems, complex systems, is the next big challenge that we'll face. So, we need to think differently about the next 20 years than the last 20 years. And that's kind of we are in a turning point era right now.
No, no, no. You bring up some excellent points, Dr. Kumar, and we're kind of diving into our topic here because you've mentioned some top use cases for AI over the next decade or 2 decades, and we're definitely seeing that when we look at the ecosystem as part of our work at ODSC and AI Plus, and we're seeing yeah, adaptive learning is interesting because we saw a lot of adaptive learning in the classroom context, not the modeling context. Um, in the last couple of years, like Squirrel AI, I think is still doing that. Seems to have died off a little bit, but I get what you're saying. And technology in the classroom is somewhat controversial in certain areas. But definitely, you touched upon manufacturing, agriculture. Um, we are seeing a lot of innovation there, and it's mostly coming, I think, through research, of course. Um, because when I attend these academics like AI for Climate and well, is very big, but also we're seeing a lot of funding in the startups, right? So
Yeah.
startups is a lag effect. No one hears about them until they're actually starting to have an impact. So I definitely see that. It's amazing. So what are some of the other use cases that you're excited about over the next decade? And maybe a hanging question onto that is like, do you think COVID's accelerated this some of these AI use cases? Or
Yeah, definitely.
yeah,
Yeah, I think one of the things that the way we look at the world now is we have seen that the silos that we have created within an ecosystem, right? So if you look at retail, for example, we have silos on front end, back end of retail. We have silos in healthcare. We have silos on pharmacy world differently, test labs, insurance companies, patient healthcare, public healthcare, right? So these silos are creating a lot of problems, and they were needed because we were not able to think the whole, but the parts. We did great job at the parts, right? And I think now is the time to integrate. So the next 20 years, we are going to see integrated ecosystem products like a smart city, like a healthcare ecosystem of a country, like the agriculture ecosystem of a country. What that means is completely different than the ability to build 1,000 models and deploy them at scale.
right,
The whole is definitely greater than the sum of the
right.
parts. We need to integrate sensors on one side, decisions on one side, notifications, and all the analysis at 5, 10 layers of analysis that can be done together, right? So this integratedness of our social sectors, our manufacturing sector, our HR and education sector, upskilling sector, all this is going to happen uh, in the next 20 years. And this integration is where the next innovation will be. As in, we know how to build boxes, we still don't know how to connect them all. We don't know if we have identified all the boxes yet. There are a lot of gaps. And my take is AI alone is not enough, right? So AI
Oh,
combined with
absolutely. Yeah.
lot of IT, lot of blockchain, lot of AR, VR, and content delivery together is going to do it. So the all of us will have to open up our minds and say, look, I'm bringing one part of the puzzle. Somebody else will bring one part of the puzzle, and together we'll integrate and create a smart city. So we need great cameras, but we also need great vision systems. We also need great notification systems. So that the whole thing comes together, right? We need optimization
Yeah.
systems, sensors, actuators, everything to come together. AI alone is not going to solve all the problems. We need to integrate this with all the other technologies. So, integration both in individual workflows and use cases for that vertical has to happen, and integration across technologies has to happen so that we see one smart city and not 10,000 models and so many sensors. We see one integrated smart city, that kind of thing. Yeah.
No, I listen to Dr. Kumar, and like it's I think it's going to be a very exciting time, and you walk into this eyes wide open, right? It's so loads of opportunities here, right? Lots of cross domain opportunities. Doesn't matter. I think AI is definitely going to be to what technology has to be in every industry. Like it doesn't matter if you're in insurance, agriculture, whatnot. You're going to use AI just like you use technology today. And then, like even the challenges are something to be they're very interesting. So we're going to have all kinds of governance challenges, accessibility challenges, privacy challenges, and then something we're starting to focus on at ODSC is adversarial AI, right? Like what happens when these
Yeah.
model goes wrong and all that stuff. And as a practitioner, as a scientist, as a someone who's interested in problems, these are all problems we have to solve. But this all sounds brilliant. So who's going to build this? What kind of skills are we going to need to build all this stuff?
Yeah, so that's the thing that I have seen, right? In the evolution of skill sets, as the technology has evolved, use cases have evolved. I think the skill sets that data scientists needs are also evolving. And today, the skill set that I talk about, one of the skill sets in one of the ODSC talks I talked about is what I call the art of formulation. So we know the tools. Like if you're a carpenter, you know the tools, but the art of formulation is how do you use the tools to build a chair or a smart city or an entire hospital AI system. And knowing that I have clustering, I have classification, I have regression, I have vision, and how to do them, how they work, what are their pros and cons, is one level of knowledge. But putting it all together correctly in what I call an AI architecture of that vertical. AI architecture of that vertical is the next skill set. So I think the word data science will still be used in the context of how do you build and deploy monitor models. But AI architecture, like IT, right? In the IT world, if you think about software engineer does one level of thing, but IT architect does a different level of thing, right? He puts it all together. Similarly, we are going to realize that a complete ecosystem doesn't need one model. It needs 10,000 models depending on how complex, right? If I have to run a refinery, every unit has its own digital twin. It is connected to another unit, and the whole thing has to be optimized end to end. If I look at telecom, I have every cell tower, hundreds of thousands of them. Everyone has to be optimized correctly in a joint way. These are not straightforward problems. So the idea is the art of formulation will become more and more important than the art of knowing how to build a model. See, the dot fit and dot
Yeah.
predict, even 12th graders can call those functions with the right input today. That has to be taught in schools and schools now, because the next level skill is how do you take domain knowledge of a domain, how do you understand the metrics, how do you understand the data, how do you understand the state of entities, how do you define how do you understand decisions, how do you understand the impact of decisions on all the metrics, and how do you then put together an AI architecture which is a series of models, one giving an output to the other, like a human body, right? We are not a collection of a trillion cells. We are doing, every cell produces something that goes into some other cell or a tissue or an organ, unless we are able to think like that. And that is the role of an AI architect who is thinking top down about the whole vertical and connecting the dots. And that skill set will have to come because AutoML will take over the other skill set. So you don't have to build models in the future. You just have to build a feature lake properly. The models will get trained automatically. They will get deployed. They will get monitored. They will do everything automatically. AutoML will go to an extreme end where the traditional job of a data scientist will become very, very minimalistic, right? It'll all
Yeah.
be label the correct data and create the right features. Everything else, AI, AutoML will do. We will not be writing Jupyter notebooks in next 5 years, right? So maybe we will, but the way I describe the role is today what we do mostly in the name of data science is what we can think of is like a cook, right? He cooks a dish, but the role of a data scientist is not a cook, but a chef. The
Right.
outcome of a chef is not a dish, although he does a lot of dish, he does a lot of experiment, but the final outcome of a chef is a recipe, not a dish. And once we understand this distinction between a cook and a chef, we realize that most of us are like cooks, right? We download some TensorFlow deep learning from here or GANs from there. Those are the guys who are chefs. They have created these great modeling frameworks, and we are just using them. We are taking their recipes, applying it to our raw material called data, right? So one of the skill sets will be, how do you become a chef? How do you invent new frameworks, whether it is deep or broad? How do you invent integration frameworks? How do you do AI at a vertical level, not at a model level? Those kind of innovations. And ultimately, we don't even want a chef, we also want a kitchen. So if I use the food analogy all the way, I think what we need now is a kitchen and a chef. And we all are cooks right now. So we need to develop these ideas of how to think about all the tools we are learning and say, I'm ready to now crack healthcare, agriculture, education, mobility, whatever. Because I need to work backwards from the pain points, from the solutions, not forward from the data. This is one mistake we do as data scientists. We
Yeah.
start with, what is
Good
the
point.
data? Because we have been trained by Kaggle to start with data and say, here is your metric and go increase your ranking. I think the next generation data scientists should start working backwards from pain points of society, pain points of industry, pain points of whatever, energy, environment, and then say, what are the tools I have, right? It's not a hammer centric world. We need a nail centric world.
Yeah.
So that point of view has to change. And because I am targeting these metrics via these decisions, therefore I need these kind of models. Therefore, I'm using these techniques. Work backward. Therefore, I need this data. As opposed to, here is my data. Therefore, this is what I can do with it. So, how do we bridge that gap of top down, bottom up is the key.
No, no, all excellent points, and you touched upon towards the end there accessibility, which we want to come back to. But your earlier point about AutoML, automatic machine learning, is a very good one. We've seen huge advance in that, and even from AutoML to MLOps, where a lot of companies and open source platforms are doing a good job of abstracting machine learning, which doesn't, in a sense, make doesn't replace AI experts or machine learners, but it does abstract it, does make it more accessible, and something I'm kind of excited about as well. And for our audience, regardless if you're a seasoned practitioner or just starting your AI, machine learning, data science career, do check out these no code or low code platforms as well. I think AutoML, a mix of AutoML and no code, low code, and other advances in the industry are going to make it quite accessible. But having said that, I'm also kind of worried because, when we started ODSC, it was all about running models on your laptop, downloading scikit-learn, TensorFlow, getting a bunch of open data. And because you said it yourself, Dr. Kumar, like pick a problem in society and work backwards. That's great. And I think a lot of citizen data scientists, for example, are able to do that. Like you can practice data science at your work, at home. But we see now the direction of AI is like you have these magnificent performance of these very large scale models with something like I think Palm has something like is it half 500 billion parameters,
Yep.
and bigger is better. And like forget about building one of these models, just even tuning one of these models is difficult. So are you concerned that as AI continues to improve, um, that it's going to become actually less accessible for the kind of tools people
Yeah.
want to use?
Yeah, I think the notion of open source will change. Today we think of open source in terms of code. Now open source will be in terms of these models, especially
Yeah,
models that cannot be managed or trained by everyone. Only these big companies with a lot of resources and data can train it. But I have a slightly different take on this. I think very, very large models uh, are great for languages where you have a lot of data, right? But if
mm,
you think of language models for languages which are, if you look at the curve of how much data is there in each language and you put them, it's a very exponential curve,
true.
right? I mean, suddenly the languages, after the top 5, 10 languages, we have very little data to even train such models, right? So that is one thing that worries me about being focused on certain things, unless we do,
Very good point. Yeah.
language stuff and all of that. That's great. The other thing is, I still subscribe to Chomsky's original, thesis when he said that, the probability of a sequence of words is an absolutely useless concept. And that's what we do, right? When we train language models, we say
Yeah.
what is the probability
Sequence
of the
model.
next word given the last. And we have thought of language as a linear thing, right? Because it is left to right, you have a tree structure on the grammar. But really, language is linear because time is linear and we are communicating in time. But knowledge is not linear. Knowledge is a graph, right? Things are connected to each other. I can give you the same graph in a different sequence of words, active, passive voice, whatever, right? So I think this decoupling of language and knowledge has to happen. Language cannot be understood in the absence of knowledge. That's another thing. So we are now working on something called knowledge aware NLP, not corpus aware NLP. So today, when we say throw only a large corpus at it, you don't need knowledge graphs, or you don't need to know the entity types and all of that. Just everything is an embedding. I think there is a little bit of thing that we are not considering, which is humans don't understand language unless we have a background knowledge about what somebody's talking about, right? So I think this a new era has to start in both NLP and vision and all of that, where we bring in some level of common sense reasoning and background knowledge along with raw data and lots of it. And if we keep increasing the complexity of the models, one aspect is what you said, accessibility will go down. But I think we'll hit a wall where we realize that embeddings is not the only answer, and the new age thinking of combining symbolic and neural is probably the correct answer, because neural alone can take us so far, symbolic alone can take us so far, and this is the next level integration that has to happen. So neuro symbolic AI is probably a better answer, because that's what I think humans are. When we read a sentence, something
Right.
becomes an ID, and it's not an embedding anymore, right? And then it has a type and all that. So I think we need a different relook at the whole thing. And just because we are able to do it in a few languages, and it's working great, doesn't mean we should close all the other doors. And I think there are a lot of scope of improvement of, because humans don't learn language the way we are teaching machines. We
Right.
don't learn billions and billions of sentences. We don't read billions of sentences in a lifetime to actually build a language model in our brain. We do something different. We don't understand images, cats versus dogs, by looking at lots of images and saying cats and dogs and all that. We don't do that. Humans don't do that. So one of my concerns with the current approach to deep learning is, we got lucky. We have GPUs and data. We got all this. I'm sure we are mimicking the brain's process a little bit. But if you think about how little labeled data human brain needs, how little human brain needs very little data to learn something very complicated. But what we are doing with deep learning today is too much supervised, very little unsupervised. So I think there is a scope of turning it around and saying, can we do this with lesser data? Then it is so intelligent. If I throw billions of sentences, then anybody can learn how to do this. But if I throw less examples and generalize more, the ratio of generalization to amount of labeled data is the key to how much intelligent a system is. And that ratio has to be a good metric of intelligence. And so I think there's scope for looking at it in different ways as well. uh, yeah.
I don't know. Absolutely. And sorry, I'm just going to take some audience questions. And I apologize; these are not necessarily in any order. Um, yeah. So I think let's see here. We had one there about. Sorry, it was just on the screen. Now it disappeared.
I think
Um,
it said, if you don't have data, how do you work backwards from use cases and all that, right?
yeah,
Yeah,
fair point. Because
yeah,
we're very interested in differential privacy, federated learning, all these systems, because I think open source data to me seems to have pretty hard limits. There's nowhere near as much out there as we think there is, and then that runs up a wall around privacy issues. Yeah, and I think that's a fair point,
correct.
because the data within a company is very solid, right? You only have data for that company. Yeah. Any thoughts on that? Because I think that's definitely a blocker going forward as well.
Yeah, yeah, yeah. So I think privacy is definitely going to remain, an important, valid area. How much data can be shared? What fields can we share? Can we reveal behavior and identity together? And that's to me the definition of
Yeah.
privacy. If I tell you the behavior, like all the features of a customer ID, but I don't tell you who the ID is, and you can never find out, then I have preserved the separation of identity and behavior, right? So first we need to kind of debate what is privacy and what is the value add that it gives us when we not violate privacy, but when we use it correctly at a statistical level, right? So we don't want to worry about individuals, but if Google can build an auto suggestion because of crowdsourced data, it is not telling you which customers did that query, but still it can give you aggregated data. So once we understand this aggregation mindset and clearly define what is allowed, what is not allowed, then I think and obviously some people will try to misuse, and we need to worry about that. Security is a big risk. How do you store PII information separate from the pure IDs, which are not reversible? So there are a lot of such issues on security side, on data sharing side, that we need to work on. But I think there is a lot of value, for example, in public health. I want to know how many patients of this disease are coming up in this area in this time of the year. Now, without violating privacy, I can give you the count, and that's a good thing, and all of that, right? So I think, yeah, we need to find a fine balance between all these issues of
Yeah.
privacy versus value and innovation. And I think the regulations are coming. Some of the countries are ahead. Uh, we're going to continue to refine them. The debate will continue, and as long as we are all eventually going to be comfortable with where we settle down, because the value to be had and the dangers that you could have, right? With great power comes great responsibility, right? So I think that
Yeah.
we'll find a good sweet spot, I'm sure, with all the debate going on around this.
And a lot of these issues are very prosaic. They're not high level issues, very low level issues, because there's a question. There's actually I think it's more of a comment from Rohit Pandey, and he's saying, what is your comment in the computer vision field? For example, X-ray scans are not compatible across different devices in hospitals. You can read it there. And actually, this is interesting because this ties into what you're saying about standards, healthcare. And I was helping 3 or 4 years ago when federated learning was first coming out, and explainability and how do you model and encrypted data. I was helping this small conglomerate of community banks um, try and figure out some modeling to do fraud detection. And the issue became very apparent was like they were all different banks. They weren't using all the same system. The data sets were completely different, and it was almost impossible without having access to the data to transform the data. So,
Mhm.
a lot of these things we're looking at right now, they work awesome in the lab, so to speak. But once you get out into the wild, you come up
Yeah,
against all kinds of problems. And I think
yeah,
Rohit's example
yes,
is an honest example of the challenges ahead that are very, very
yeah,
at ground
yeah.
level, so to speak.
Yeah. See, I think the key to this is the more general the data is. That means across sensor types or gradations of sensors, the more it will pick the general features, not the sensor specific feature. We understand that, right? For example, if you build a face recognition model with certain group of people, it is not going to work on another group of people, right? So the more general the model you want, the more general the data you need. So I'll give you a case study. This happened 20 years ago. What happened was, when the credit card started coming, and this was before cell phones and OTPs. What happened? The credit card fraud went up. Now every bank started building their own credit card fraud models, but they had a very limited view of what is fraud, what is not fraud from their own data, and their fraud models were not good enough. And then companies like mine, back in the day, we came together and said, look, we are all facing the same problem. Why don't we combine anonymized data and build a very robust fraud model for credit cards that all of us can use? This kind of consortium thinking, right? And we are talking about credit card companies and banks who are willing to share anonymized data just to solve a common problem that they all had. And this kind of approach has to come, that when all the X-ray companies and all the hospitals come together and they don't sit and say, this is my data, this is your data, we're going to keep it separate. Once we start to kind of come together and combine data without worrying about privacy or making sure it is taken care of, then only we'll create more general models than sensor specific models, right? Or models which are specific to one country or one type of sensor or one version of the sensor. So I think explainability in terms of sensor parameters, as well as grouping things together across multiple X-ray scans across different kinds of devices. All of this will give us a much better model than this is how the radiologists are. They don't care
Right.
about which X-ray was used, right? They know how to read it without the device coming in the way. So AI can reach there because we are able to build a consortium thinking, right? Not just federated thinking. Consortium thinking has to be brought in. Yeah,
Great. So, Dr. Kumar, I want to wrap this up because we've had a great conversation here, but we're coming close to
sure.
40 minutes, actually a little bit over it. So you're speaking at ODSE APAC next week.
Mhm.
Anyone can access that talk. Just log in. And the topic is towards reasoning-based conversation systems. Can you tell us a little bit about that session? What people can look forward
Yeah, yeah. So, we are doing great job at building different types and different levels of sophistication of chatbots. And this area is very important. I have seen how it is evolving. I was part of the Google Allo team in the beginning and, all of that. And different approaches have been used. But to me, chatbot is not an NLP problem. It's more of a reasoning problem. If you look at the conversation
Interesting.
you and I are having, it's not just NLP. It's really about, making sure the conversation flows, the questions are asked and the follow-up questions are connected. So there is a notion of efficiency, connectedness to a conversation. Every conversation has an end goal, whether a doctor-patient conversation for diagnosis has an end goal. So how do we think about conversation more or a reasoning problem? That is one part of my talk. I'll talk about multiple levels of reasoning, whether it is complex question answering or building a diagnosis system. These are the two kinds of deep dives we'll do. But really, the goal is to pose, look at conversation level systems from very simple to very complex. What is the space in which a conversation system lives, and how does that space become more and more complex? And so I'll propose like 7 8 levels of conversation
Excellent.
system, starting with Google search is also a conversation system. Just a keyword search is like a
Right.
level 0 conversation system. And then you talking to Albert Einstein in his avatar and having a free flowing conversation is also a conversation system. So what is that spectrum? How do we think about that spectrum and then see where we are, what we need at different levels in the spectrum, and why reasoning is an integral part of chatbot thinking, because that's where we want to go. And really, what I want to hint at, which is for the future talks, is how reasoning thinking will lead to artificial general intelligence more than just deep learning thinking. Reasoning is a very different kind of thinking. It's on
Right.
symbolic data and all of that. And once we understand that, wow, reasoning is a very as important part of AI as deep learning is, then we'll start to use reasoning systems more and more. And I want to kind of hint at, how powerful they can be, how difficult they are, uh, and how generalizable AI can become if we get them right. And that is when artificial general intelligence will start to see one growth of AGI is going to happen via reasoning pathway, not just a deep learning pathway. So hopefully all this will come together nicely when the talk
No,
happens. Yeah.
I'm actually quite looking forward to that. Um, yeah, and it's a fascinating whole topic. We're looking quite closely at how models hallucinate and playing around with GPT-3, and we were just playing with that example of Albert Einstein and asking the questions about Albert, and it was coming up with these hallucinated answers and all that good stuff. So yeah, lots of challenge and opportunity there. But Dr. Kumar, you are an absolute AI rock star. Thank you
Thank
so
you.
much for being this show. That was an incredibly insightful conversation, and I think our audience will agree. Thank you to all our attendees from joining us from Pakistan, from India, from Czech Republic. Um, sorry from the US. Sorry from leaving everyone out here, but You've been a great audience as well. Lots of questions, lots of comments. So, Dr. Kumar, we'll see you again.
Yep. See you.
Bye
Thank
now.
you. Bye. Bye.